you can also lose your money, okay? There's higher risk, but there's also higher reward. So let's make a hypothetical situation here. Let's leave it in, oh wait, you know what I forgot to do? Sorry, we forgot part B. I'm sorry, let's do part B. I don't want to do a different problem yet. For part B, I said, how much is there if it's compounded what? Continuously. So when you see the word continuously, you're going to use the other formula. Okay, that's the key word right there that you use, that will let you know you need to use the other formula. Now I call this the shampoo formula. Has anyone ever heard of PERT? PERT, the shampoo? They still make it. It's good stuff. Pardon? The green bottle? The green bottle, yep. Yep. PERT. It's good stuff. That's the formula we use if it's compounded continuously. Now this is a very difficult concept to make sense. Remember how I said if like n is 12, that means they're gonna do the interest 12 times, but they're gonna do it on a small piece? Yes? Continuously means they are actually calculating the interest all the time. Every instant of every moment of every day, of every second, it's always compounding the interest. But it's compounding it on a very small piece. And this is where the calculus gets involved. You have like these ideas of infinity, and all we need to know is that when you do that, that ugly formula that we just used becomes this formula. And this formula is much easier to work with. So let's see how this would work out. P is 1.5 million. E raised to the R, what's R? 0.032, right? Times T, but T was 1. Okay, so there's our interest rate. Notice there's no N in this formula, right? There's no N. So when we do this, what we have to do first is multiply that together, which in this case is just 0.032, right? So now on my calculator, or on your calculator, you have to figure out what E raised to the 0.032 is. Figure out what that is. And this is where you need to practice and make sure you can get the same answer that I get. And if you don't get it, you need to let me know. That way we can figure out how to do it on your calculator. You should be getting 1.032517505. That's what I got. Just go out as many decimals as you can. Did anyone get anything different than this? Trying to get e to that power. Did anyone get something different than this and need help on their calculator with it?
Wait, how do you do that?
Okay, let me see yours. Okay, so you're going to hit that blue button first, okay? And then that button right there. Oh, sorry, I drew on your thing. Do you see that? And then put in 0.032. And then you can just hit enter now. Got it? Who else? Anyone else need help with it? Take that and multiply that by that. $1,548,776.26. That's the answer I got for this one. Who else got something close to that? Yes? Got that? Okay, what was the answer for the other formula? It was 15487. It was 710? So that's a pretty big difference, right? That's about, what, $60 difference? Over the period of the year, a $60 difference? Most financial institutions use this formula because it's easier to calculate. Like that was a much easier calculation than the other one, right? But it looks like they'd be giving you more money, right? A little bit more money this way? But remember, they're also loaning out money, right? And the people with the credit card debt also have to pay that more. So it works out for them. All right, let's do something else. It's pretty crazy if you think about this. The way this works, I only have 10 minutes left. Are y'all okay with this? Imagine you win not 1.5 million. Imagine you were to win a $15 million lottery. You walk home with 15 million, all right? Just move the decimal point one place over, $15 million. If you go put that in the bank for 1 year at 3%, all that changes in the formula is the decimal point moves over once, which means that instead of making 48,000, how much do you make? 487,000. That's crazy, right? You have $15 million, put it in the bank for 1 year at a pretty modest interest rate, and you're making $500,000 a year just to sit on your money. Right? I don't think you need a job, do you? If you use that money properly and don't just go blow it all at one time, you can just live off the interest alone. So think about these like billionaires, right? People who have billions of dollars. What would it take to get to $1 billion? Let's see, we're here, 15 million. So if I move it over one more spot, right? That person right there, a person who's worth $150 million, makes how much money off of that money in this problem? Makes how much a year off that money? Move it over one spot, so instead of 487,000, they're making 4.8 million. 4.8 million a year. And if I move it over one more, there's where we get to $1 billion. So you have a billionaire can make like $48-50 million a year just off their money. Oh, crazy. Where the lottery winners, I think, get into trouble is they go buy all the stuff they want. And what they do is they take, you win that, let's say 15 million, right? And instead of doing the right thing and investing it and saying, okay, I'm going to just live off the interest and make 400 grand, 500 grand a year off of it, which you can have all your house and boats and shit like that you want. Just be patient, wait for the money. They go and they blow all of it right away, and then they don't have that thing to sit on and gain interest off anymore. They go buy cash, everything. Go buy the boat, the car, the house, and next thing you know, they've only got $1 million sitting in the bank. They've got a $5 million house that they can't afford the property taxes on, that we were talking about the other day, right? And so it's all gone. But if you do it right, you can just live off your own money. All right. Let's go to the other end of the spectrum. Let's say you owe, right? You have a credit card. Let's say you owe. How much do you want to owe? 40,000? Let's just go with something like 8 grand, okay? Let's just go with 8 grand. You owe 8 grand. You've got it all on a credit card at 20%. Now, this is not really a true representation of the way credit cards work because credit cards do have minimum monthly payments. But those minimum monthly payments really don't do anything to bring down the balance. So it's almost like you're not making a payment at all. So this is going to be a model that kind of shows you what happens if you just do the minimum payments. Let's say that it takes, how long do you want to pay it off? How many years do you want to pay that 8 grand off in? 2 years? It takes you 2 years to pay it off. How much interest did you pay? By you, right? So, and let's do the compounded continuously so we can use the easier formula, right? And because I only have 5 minutes. Okay? So, what's the principal? We're going to use this formula. What's the principal amount that we are starting with? 8,000. So this becomes 8,000 e raised to the interest rate, which is 20%, 0.2, times t, which is 2. So we're going to do on a calculator 0.2 times 2, which is 8,000 e to the 0.4. And now do e to the 0.4 take that number and multiply it times 8,000. So I got 8,000. When I did e to the 0.4, I got 1.491824698, something like that. And when I multiplied, we got 11,934.59. 60. So how much interest did you pay?
8,000.
You take that and subtract 8,000 from it, right? So you wound up paying $3,934 in interest, right? Which is really what percentage of that original amount? If I asked you, this amount is what percent of 8,000, then you would take that and divide that by 8,000. And you will see it is not 20%. What is it? Anyone do that? This divided by this. What if this was 4,000? Right? What if this was 4,000? Then what percentage did you pay in interest? You borrowed 8,000, right? If you paid, like if this was 12,000, this would be 4,000, right? It's like 50%. The 20% is not really 20, that's an annual percentage rate. When you start accumulating this over time, you actually paid this much back, right? Which means you paid this much in interest, but you only borrowed that much. So that $2,000 TV that you wanted to get from Best Buy, right? That's sitting in there, you can play your video games on it, right? That $2,000 winds up costing you $3,200, right? After you pay it all off. So I'm not here to teach you any lessons. This is the way it works. Try and keep yourself out of debt. I know it's hard to do, but try and do it. All right. I'm going to put a reminder in my phone right now to send you all a review for the test. It'll have some of this interest stuff on it. It'll have some stuff where I give you an exponential function, ask you, tell me if it's growth or decay, right? And then other stuff. All right, I hope everyone has a good weekend.